Dear students, we are now studying chapter 1, motion along a straight line of your physics class 11 textbook. Now, in that already we have covered certain topics such as uniform velocity motion as well as with constant acceleration motion using equations of motion. Now we'll take up the same constant acceleration motion along a straight line but graphical kinds of questions. That is okay. Now, as you know already, what are the variables which are involved in this one-dimensional motion is velocity. Let me just velocity, symbol V, displacement first of course, symbol S, acceleration, symbol A, and of course independent variable usually time t. Now these are the four variables which are involved, and therefore now the graphs can be made along x-axis, y-axis graph. Now along x-axis usual variable which is used is time t, and therefore along the y-axis it can be displacement or it can be velocity. That is the usual type of graphs. Sometimes you will have acceleration with time, of course, is a case of non-uniform acceleration. Right now we are restricting only with reference to uniform acceleration. Therefore, such a kind of acceleration versus time does not come in our topic now. Then you can have velocity versus displacement sometimes. Okay. Therefore, now these are the possible three graphs which will be given in the question. Then what are the things which are involved is, now let us say, now for example, now S versus T graph may be like this. Okay. If it is like this, then the slope of this is going to give ds by dt, as you know, is the slope which is going to give you therefore velocity. Now if it is a straight line graph like this, it means the slope is constant, that means velocity is constant. Now if we are, since we are right now we are dealing with constant acceleration, the slope is not going to be constant, that means velocity is not going to be constant, velocity may be varying like this. Therefore then what happens is, what a velocity is, slope at any point, any t. Let's say now at this time t, what is instantaneous velocity given by the slope of the tangent. Slope of the tangent which is given is, now this is nothing but theta is equal to tan theta, whereas, and therefore we know that the slope ds by dt stands for the tan theta, which is the angle which the tangent makes with the x-axis. In this case, x-axis is nothing but time axis, t. Therefore, this gives the instantaneous velocity. Therefore, as we know that our topic is right now is going to be constant acceleration motion. Therefore, now S versus T graph will be quadratic, so that the slope varies from point to point, that is from time to time. In which case, then the velocity versus time graph will be a straight line, like this. Now, initial velocity, we know the symbol is u. Therefore, at any time t, this will be the instantaneous velocity v, and therefore now slope of this is going to be acceleration defined as dv by dt. It is going to be constant. Therefore, it will be a straight line graph. V versus t will be a straight line graph, so that acceleration is constant. This we know. Now, sometimes you are given the graph v versus s. Then what happens is, as what we have now covered here, now this is ds by dt, this is acceleration is going to be dv by dt, whereas now sometimes you are given dv by ds. That means acceleration is going to be like this. Why? Because acceleration which we know is dv by dt can be expressed as dv by ds first and then multiplied by ds by dt, because this can get cancelled out. Therefore this means this is what? This is v dv by ds. Therefore now if we have this v versus s graph, something like this, then what happens is, then acceleration is given by at any point. This now the slope here is dv by ds, dv by ds multiplied by v is going to give, multiplied by the v here, this is v here. Therefore, instantaneous acceleration is going to be given by v into dv by ds. Therefore, now question may be asked based on the graphs given, and therefore now making you to use the slopes definitions as well as the slopes which you can make out from the geometry of the graph which is given. Therefore, now this is based on the slopes. Of course, now later on we are going to now deal with areas. Now, what are the this thing for the same this thing? Suppose now you have this particular graph, velocity versus time graph is like this for a constant acceleration. Then the area of this graph under this straight line graph, this area is going to represent S. Why? Because we know that ds by dt is equal to v. Therefore, v dt is going to be ds. Therefore, integral v dt, which is actually standing for area, is going to be delta s. Delta s is now nothing but displacement s. Therefore, this area is going to be, because why we say now delta s equal to s, because initial starting position s equal to 0. Therefore, now delta s equal to the full displacement itself. Therefore, area under the vt graph is going to give you this displacement. Now, similarly, now you have area under acceleration time graph. Acceleration time, because constant acceleration we are dealing with, it will be a straight line graph like this because constant acceleration. Therefore, at any time, what the area which is given is a into t. A into t is nothing but the change in velocity, because a is constant. Therefore, they going delta v, which is nothing but v minus u, that is the final velocity minus initial velocity. Therefore, now these are the two graphs which will be given during your. Therefore, now we have studied all possible graph questions which you will get. There may be some more kind of graph question which you get, which you will have to solve them based on these definitions which we know: v equal to ds by dt, and then acceleration equal to dv by dt, as well as acceleration equal to v dv by ds. Based on this, as well as now area v dt integral will give you displacement as well as a dt integral, which of course for a constant acceleration a can take an outside. Therefore, a delta t is going to give you the change in velocity. Therefore, with this basis, we will now attack some other kind of a question which have been asked in the past, especially NEET. As I said, we are dealing with the fundamental level of the question. Therefore, most of the question what we will be dealing, or why most of the question, all the questions which you are dealing now in this session will be based on the past asked question in the NEET examination. Of course, as I have been saying, there will be separate session for JEE questions, past question which will be asked, which will be slightly more difficult in the nature, which is of course aimed for the JEE preparing students, which will be a separate session which you will go through. Now, right now, as I said, we are now attacking the fundamental levels of the concepts by means of questions. Therefore, we will now take up some of the past asked questions based on the needs. Graphical questions is what we are going to deal with. Now take this particular first question. Read the question carefully, understand it, and then select the option as what you think. Now, the velocity versus time plot of the motion of the body is shown as like this. Okay, now this is the one which has been used, which is the one that has been asked. Look at this question, read it carefully. The velocity versus time graph of the motion of a body is as shown. Now this is velocity versus time. Velocity versus time graph is shown. It now consists of three parts. One is now increasing from left to right, then it is constant velocity with time, and then decreasing from left to right. That means now the slope here is positive. Slope on this particular part is positive. The slope here is 0. Then the slope here is negative. Okay, what is the slope is in this case? Is nothing but velocity was time graph. Therefore, dv by dt. dv by dt stands for acceleration. Therefore, acceleration is positive during the first part. Acceleration equal to 0 in the second part. Acceleration is negative in the third part. Then this thing is, now slope is constant for a straight line. Therefore, acceleration is positive and constant for the first part. Acceleration is 0 for the second part. Acceleration is constant and negative for the third part. Therefore, now this is what you must now look for. Now, this now, therefore, now this obviously looks for, that is point 1. Acceleration is constant positive, then it is 0, then it is negative. Therefore, this must be the correct answer. Okay. Next question. Now the displacement time graphs of two moving particles make angles 30 degrees and 45 degrees with the x-axis as shown in the figure. The ratio of the respective velocities is. Now two particles. Now this is displacement versus time. That is s versus t. Therefore, now the slope should give you ds by dt, which is equal to velocity. Now because it's now a straight line, therefore ds by dt, that is slope is going to be constant, means velocity is constant. And because now the two straight lines represent the two different particles, first particle has got a straight line like this. Now let us say, now straight line, therefore now it's got a constant slope, which means now ds by dt is constant, means velocity is constant. This velocity is constant for the particle, and also now it is positive, because now slope is positive and increasing from left to right. In displacement versus time graph, ds by dt, slope is positive because now slope is constant because it is a straight line, point number 1. Point number 2, slope is positive because the line is increasing from left to right. Therefore, this is a constant velocity here. What is now the slope which is given as 45 degree mean? Therefore, tan theta is a slope for a straight line. Therefore, tan theta is equal to tan 45 is for the first particle. If you call this as first particle, call this as now second particle, then tan 45 equal to 1. Therefore, now this velocity here is constant equal to 1. Velocity here is constant equal to what is now tan 30. Tan 30 is 1 by root 3. Therefore, now then what is the ratio? 1 is to 1 by root 3. This is nothing but multiplied by root 3, you get root 3 is to 1. Therefore, the fourth must be the correct answer. Okay, simple questions. Now some of you NEET preparing people may be fairly weak in mathematics. Some of you may not have taken mathematics as part of your subject in your plus 2, and some of you who actually taken mathematics may also find it actually they are pretty weak in mathematics. You have to brush up your basic mathematics knowledge, geometry, trigonometry, as well as some of the coordinate geometry. Especially coordinate geometry will be very useful for your physics understanding. And of course, naturally, calculus you have to be very strong with. In addition to it, you should be pretty good in basic algebra, solving equations, quadratic equations, and so on and so forth. You must be agile. You must be very skillful. You must be very skillful in manipulating numerical data, symbols, algebra, arithmetic, and so on and so forth. Unless you are like this, you will find it difficult. In the sense, you may be able to solve a problem, but then you will take a long time. Therefore, it will defeat the whole purpose of trying to get maximum marks. Therefore, please tighten up your mathematics in case you are weak in it. Now let's continue for this. Question number 27. Now the particle shows distance time curve. Now distance along y-axis, time along x-axis. Now this is now a curve. Therefore, now the slope is going to vary because it is a curve, and the slope is nothing but distance was a time graph. Slope is nothing but ds by dt is going to be velocity. Therefore, velocity keeps on varying with time because of the curve like this. Now the questions will be based on the velocities. The maximum instantaneous velocity of the particle is around the point. Now, wherever the maximum slope is there, that is called the maximum velocity at that particular instantaneous point. Therefore, now where can be the maximum slope is there? Now imagine a tangent. Now tangent here is going to be like this. Where tangent here is even more, having more slope. Tangent here is becoming lesser slope. Tangent here is almost equal to 0. That means around this point. Where is this point? This point is cutting the time axis. Let us say now point A. They have marked point A. They have marked point B around here, point A around here. Point C must have been here, but they have forgotten to mark it point D. Therefore, around point A is where the maximum slope is. Slope is ds by dt representing velocity. Therefore, this answer must be point A. Understanding? Next. What is this? No, this is around point A. Therefore, option D. Next. Okay. The car accelerates from rest at a constant rate alpha for some time, after which it decelerates. Now, the one advice to you is, whenever you have to draw a graph, it is always better to draw velocity versus time graph. Why it is always better is because velocity happen to be in between displacement as well as acceleration. Okay, let me just explain what I am now saying. Now, the velocity is given by the differential ds by dt, as well as velocity into dt integral is going to give you acceleration. Therefore, now velocity is the intermediate between, because s is a top level, then ds by dt is going to velocity, and the dv by dt is going to be acceleration. Therefore, now it is better to draw the velocity versus time graph wherever possible, so that now the slope of this velocity time graph is going to give you acceleration, whereas area velocity time graph is going to give you displacement. Therefore, you can go one step ahead or one step down, so that you can actually attack questions based on asking for displacement by means of taking the area, as well as asking questions on acceleration by means of taking the slope. Therefore, always preferable to take velocity or time graph. Now, having said that, let's just now continue our questions, reading the questions. Okay, here car accelerates from rest at a constant rate alpha for some time, after which now let us now continue to draw this. As I said, always try and draw velocity time graph, and then put the data given in that graph. Now let's now take the first sentence. Car accelerates. Therefore, now velocity time graph, if it is now slope is increasing, accelerates from rest. From rest means velocity equal to 0. It now starts with 0, and then acceleration, constant acceleration alpha. That means it will be a straight line because constant acceleration alpha. Therefore, now slope is equal to alpha. Slope is a constant acceleration alpha for some time. Okay, up to this time, from 0 to this particular time. Okay, next, after which you decelerate at a constant rate beta and comes to rest. Comes to rest means velocity becomes 0. That means under deceleration means retardation. Retardation means negative acceleration, or the slope is negative. That means it is now reducing straight line like this. Therefore, now this is equal to beta, right? And then comes rest. Comes rest means velocity becomes 0 at this end point. Now, if the total time elapsed is t, that means from here to here it is called t. This point is t. This point is now 0, t. Then the maximum velocity acquired by the car is, what is this velocity? But because this is now the maximum velocity is v max. V max is equal to what is the question? Right now, one thing is clear. Now, if you just look at these two triangles, right? These two triangles. Now the height is going to be given by slope into base. What is this base? This, let us say, is now T1. This is, let us say, is, let me just write, this is now T1, and therefore this is now T2 balance, and therefore T1 plus T2 put together will be equal to total T, which is given data. Now, because now this is alpha into T1 is the height of this particular triangle. Okay, now alpha is a slope, and then T1 is the interval. Therefore, this height is equal to alpha T1, and also it is equal to beta T2 from this particular other triangle, beta T2. That means T1 is to T2 equal to T1 by T2. You take it as equal to beta by alpha, because alpha T1 equal to beta T2 from this. Therefore, T1 is to T2 equal beta alpha. Therefore, T1 should be equal to beta by alpha plus beta times T. Okay? No, this is what I said about you must be sharp with mathematical skills. Why? Because now T1 is to T2, you should be in the ratio of beta is to alpha, and also now T1 plus T2 equal to total T. Therefore, expressed in terms of this, the T1 should be equal to beta by total times T. And of course now similarly T2 should be equal to alpha by alpha plus beta times T. Therefore, now this is what I meant by means of saying that you should be sharp in mathematics in order to succeed well in this examination. Anyway, now let's now continue. Therefore, now T1 equal to this. Therefore, from here, what we know is we are asking about V max. V max is equal to, you take any one of them, which is alpha T1. Alpha T1 is nothing but alpha into beta divided by alpha plus beta times T. Therefore, this must be the answer what they are looking for. Alpha beta by alpha plus beta times T. Where is it? Alpha beta times T. Understanding? Option D. Now go to the next question. Displacement time graph of a moving particle is as shown below. Now displacement time graph, therefore now the slope has to give you velocity. And of course naturally they are going to ask about the velocity equation. So the velocity of the particle is negative at the point. Therefore now wherever the slope is negative, it means ds by dt is negative, means velocity is negative. Therefore then where is the negative? When it is actually a dropping curve. Now this part up to this is now increasing curve, whereas this part is a decreasing curve. Therefore now here in this part velocity is equal to negative. Now here at the point D, now the slope is going to be 0, that means velocity is going to be 0. Whereas at the point E, it is negative slope is velocity. Therefore, this must be the answer E. Because at this point again it is going to be 0 velocity. Because slope is 0. Therefore, now this thing is near the point E. Okay, simple questions. Now we are going to simple questions. Of course, if you are a JEE student, then you must practice much more tougher questions which you will come across in the JEE exam, which we will see. As I said, there is another video which is essentially devoted for JEE Main as well as advanced level of questions what is asked in the past, which you can master, which you can practice. That will give you enough confidence to face your JEE exam in this particular graph type of questions. Now let's now continue the NEET level preparation areas. Now so far we have considered the slopes and therefore answering questions based on the slopes. Now we will consider the questions asking about areas. Now area under, as I said about, there is going to VT graph is going to give you displacement. AT graph is going to give you change in velocity. Of course, AX graph also is going to give you the V dB by dx. Okay, no. Therefore, now we'll consider these kind of questions. Where are the questions? We will see. Yeah, unfortunately there have been no questions asked in the past examination. Therefore, we will just look for. I'll get you some questions so that it will be a good for practice. Yeah, just hold on, just wait. I'll get you some questions on this type. Okay, let's take the question number 1. Yeah, just read the question. The motion of an airplane is represented by a velocity time graph as shown below. The distance covered by the plane. Now, look at this. Now, this is velocity time graph. Velocity was a time graph. Therefore, now area will give you displacement. Now, in this, then the one thing more also you'll have to know is, now any area above the x-axis, above the time axis, is going to be positive. Whereas any area below the x-axis, below the time axis is going to be negative. Therefore, now you should be careful. If the question asks for displacement, then you must take the positive area as positive and then subtract the negative area. Okay, that means you should take the algebraic sum of the two areas. That means that plus area and then subtract minus area in order to get the displacement. Then if it is distance only, then irrespective of whether it is positive area or negative area, you have to take the modulus value and then add them up. Okay, now in this particular graph, luckily there are no negative areas, everything only positive. Now they are asking about what is the distance covered by the plane in the first 30.5 seconds. That means now this is 30, this is 30.5, you must take now, which means you must now add up this area of this of the trapezium plus another rectangle of this. Okay, therefore you know how to calculate the areas. You calculate it like this. Now if I just do it for you, then like this. Now this is now this consists of a trapezium. Therefore 200, 400, average is 300. 300 into 2 is now 600. 600 is this particular part of it. 600 plus then you have to take up to 30.5. You have to take. Therefore 30.5 means this is from 2 to 30.28.5 is the base multiplied by, now altitude is 400. Therefore then you multiply by 400. Therefore 30 into 400 minus 1.5 into 400. 30 into 400 is equal to 12,000 minus 1.4 is 600 subtract. 600 add, 600 subtract over, therefore 12,000. Okay, now therefore equal to 12 kilometer is the answer. Understood how it is done? Good. Now I'll take the next question, number 2. The question asked is velocity time graph of an object. This is the question which I want you to go through. Velocity time graph of an object moving along a straight line is shown as in the figure. What is the distance covered? Okay, again it is now distance covered, and then luckily there are no negative areas, therefore only positive areas. Therefore distance will be equal to displacement also. In any case, they are asking for distance covered by the object between t equal to 0 to t is equal to 4. That means from here, which means this is area to be calculated. Therefore simple only. Okay. Now these are all, in fact, these are all asked in JEE in 2025. They must be very, very simple, very easy to score kind of questions. Then you go to question number 8. Where is it? Okay. Now look at this question. Question number 8. Statement 1. Area under velocity time graph is distance traveled by the body in a given time. Area under velocity time graph actually gives you displacement. Anyway, now I don't know what they are meaning by this. Let's just wait. Then the area under the accident time graph is equal to change in velocity in the given time. Yeah, this also is true. This also is true. In the light of the given statement, choose the correct answer from the options given below. Both statements 1 and 2 are true in the sense. Okay. Now it's not actually distance. It gives you displacement. Gives you. Okay, area under the time graph, velocity time graph. Because if it happens to be a negative area, then it does not give you area and time graph. Strictly speaking, is algebraic addition, algebraic value. Therefore, it's not the absolute value addition. Therefore, this part of it I would feel is not correct. Statement 1 is incorrect because it gives you only displacement, not the distance. You understand? Okay. Now this is the kind of questions what you get. Then shall we go through one more question of this nature? Question number 11. Where is question number 11? This question number 10. Yeah, question number 11 is here. This question number 11. Okay. Now let's take this graph. Velocity time graph shows the ratio of distance to displacement in 25 seconds of motion. 25 seconds up to this. Therefore, now if it is distance, then we have to take this area, we have to calculate plus this area and add them up, that gives you distance. Then if it is now displacement, what happens is, now this is 5, this is 5, and then the same slope. This is 20. Actually, it means displacement will be only the area up to this alone will give you. Why? Because this area positive will get cancelled with the area negative. Therefore, there is no need to calculate this area up to this. Whereas for your distance, you have to actually not double this. Doubling this also is nothing but you can take the congruency and undertake this particular rectangle, add them up. Understand? Now area calculation and all that, I don't want to teach you that because that's all very, very basic. You should be able to handle it well and then fast as well as do it correctly. Now the only thing what I can give you some sort of a shortcut tips like this for a displacement. Now this area cancel with this area, therefore you can actually now take only up to this, whereas for distance you have to add this area plus this area also in addition to this area. Therefore now you can take the ratios well. Understand? Then question number 11 is over. Then I have one more question to be taken care of, that is question number 40. Yeah, just wait, let me now locate that particular question. Question number 40 will take some time. Question number 32, 33. Yeah, we come to question number 40. Okay. A velocity time graph of a body moving in a straight line is shown again. Now all these things are very basic. Velocity time graph is all questions whatever we have come across is basic velocity time graph. You should be prepared to tackle some other questions also, because as I said, now area under acceleration time graph would give you change in velocity. That type of questions also you should be able to do. Okay. Now yeah, this also is like this. Then we will go to question number 65. That should be interesting. Just one second, let me just locate that question number 65 for you. Just read question number 65. Particle is moving in a straight line such that the velocity is increasing at 5 meter per second per meter. 5 meter per second per meter. That means now this must be a graph between velocity versus displacement, because now it is per meter it is given. Therefore, this actually is velocity versus displacement graph, which is velocity increasing at the rate of 5 meter per second per meter. That means now the slope equal to 5 value. Okay, this of course is meter per second. This is of course its displacement is meter. Okay, now the slope is constant 5. The acceleration of the particle is how much? Okay, this actually is the answer, but I want you to work it out now. Now at a point where the velocity is 20 meters. When the velocity is 20 meters, this is 20. What is the acceleration at this particular distance? Yes, what should be the acceleration? Now this actually is nothing but acceleration formula. We can use it as v dv by ds. Okay, this is a formula from your this thing, because how we got the formula? Because acceleration is given by dv by dt, which can be written as dv by ds and ds by dt, where now ds by dt can be replaced with v. Therefore, v dv by ds is acceleration formula. One more type of formula. Okay. Now, what is now dv by ds is a slope of the velocity displacement graph, which now in this case is given as constant equal to 5. This particular slope value is 5. And then what is the velocity at what point you want the acceleration is? Velocity given as 20 at this point. Therefore, now 20 into 5 is 100. 100 is the acceleration at that point. Understood? Okay, good. Therefore, now we have covered enough kind of a practice questions. You can actually do your own practice questions some more also, and then get used to solving such kind of a graphical questions. Okay.